Today we are going to see LCD interfacing with 8051 microcontroller. In previous two lectures we have seen the interfacing of LED and interfacing of 7 segment display. Here are our course objectives. We will be seeing the principle of interfacing and programming. That is, today we are going to see is LCD interfacing. So LCD display is going to be interfaced with the 8051 microcontroller. Let us see the details of LCD we are going to interface. This is 16 by 2 LCD screen. 16 by 2 means 16 characters per line and there are 2 lines. Here is the line 1, here is the line 2. Why 16? Let us count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 characters per line and there are 2 lines, hence it is called the 16 by 2 LCD. Let us see the pin function of the LCD. Here are the pins of the LCD. VSS, it is ground. VCC, it is plus 5 volt power supply. Here it is VDD. VEE is the power supply to control the contrast. Contrast of this backlight. This is backlight LCD, means there is a light at the back of display. So you can control the contrast of this LCD, of this backlight, by using this VEE. RS is the register select pin. When RS is equal to 0, the command register will be selected. When RS is equal to 1, data register will be selected. So this RS pin is to select the register. We will be sending the data and commands to the LCD, and which will be selected according to the bit position of this RS. When 0, command, when 1, it is data. Next is the read oblique write bar. You can read from LCD or you can write to LCD. When this bit is 1, you can read from LCD. When this bit is low, you can write into the LCD. So we are writing to the LCD and will be keeping this particular bit low. Next is the enable. Enable used by LCD to latch the information. We'll understand the role of this pin while programming. Next, there are the data bits DB0 to DB7. 8 pins are involved for the actual data to be displayed on the LCD or command we are passing to the LCD. So in this way, these are the 14 pin. Pin number 15 and 16 are anode and cathode, can be connected to the positive and ground. Next, we have to understand the commands of LCD so that we can configure the LCD. These are all commands used to configure the LCD. Let us understand the meaning of these commands one by one. With 0, 1, LCD will be clear display screen. 30, it is 8-bit 1-line LCD having 5 by 7 dots. What is mean by this 5 by 7 dot? Here it is 5 columns, 7 rows. 5 columns, 7 rows. The pixels are arranged in 5 by 7 matrix, and when the particular character is to be displayed, those pixels are glow and we can see that character is displayed. So in this way, 5 by 7 is the pixel matrix where we will be displaying the character. Second, 38 is 2-line LCD and 5 by 7 dot. Each character will be displayed by this 5 by 7 matrix of the pixel. 20, it is the 4-bit 1-line. 28, it will be 4-bit 2-line LCD, and 5 by 7. Hope you understand the meaning of 5 by 7 now. 6, it is the shift cursor right. As we are going to display the letters, the characters, cursor will be moving to the right. So with 6, we are telling LCD that move the or shift the cursor to right when the characters are displayed. 8, display of cursor off. 0E display on, cursor on. 0C display on, cursor off. 0F display on, cursor linking. 18 is the shift entire display left. 1C shift entire display right. With 10 move cursor left by 1 character. With 14 move cursor right by 1 character. 80 and C0 are the position of the cursor where we can display the character. 80 is the address of the first line, first column of this LCD. This is the 80, position 80, first line, first column, and C0 is the second line, first column. So these are the starting address of the line. If we want to display the character on first line, we will be using 80 as a starting address. If we want to display the character on second line, we will be using the address C0. So these are all about the commands that is used to configure the LCD. Here are the commands I have highlighted that we will be using for writing a program. We need to clear the display screen initially. Then we will configure the LCD as a 2-line LCD. Then we will be shifting the cursor to right when we are displaying the character. Then we are using 0E to display on, cursor on. And lastly, the position we will be given to the LCD that where we want to display our character. Next, LCD addresses for the LCD, that is 40 by 2 size. So here we have discussed the addresses. 80 is the initial address for the first line and A7 is the last address of the first line. C0 the first address of the second line and D0 is the last address of the second line. Let us come to the interfacing diagram of the LCD in 8-bit mode. The meaning of 8-bit is that we will be sending the 8-bit data, and 4-bit mode means we will be sending the data in the 4-bit at a time, 4-bit. So here are the all LCD command we have displayed, that is so that we can revise the commands and we can use it. Understanding this interfacing diagram, which pins of the LCD are involved? D0 to D7 pins are involved to send the data. From port 1 we will be sending the data. Then 3 pins are used to control the LCD or given the control signal to LCD: P2.0, P2.1 and P2.2. So with P2.0 we will be telling LCD whether we are sending the data or command. With P2.1 we are telling LCD that we are writing the data or command. With P2.2 we are latching the data or command we have sent to the LCD. So in this way we will be configuring the LCD, and these are the hardware connection. Coming to this VCC, VEE and VSS, as we have discussed initially, it is used to control the contrast of the backlight of the LCD. Now we have understood the interfacing diagram properly. Let us see how to program the LCD, the algorithm for that. For configuring LCD, we are sending the commands. We are sending the commands to the accumulator. These are the command 38, 0E, 01, 0C, 80 and C0. Now we are in the position to understand the meaning of this 38, 0E, 01, 6, 80 and C0. We will be sending it into the accumulator and from accumulator to particular port. Next, we are giving the commands, that is RS is equal to 0 to say tell LCD that it is a command. Then read write is equal to 0, that we are writing the command, and next we have to give high to low pulse to enable or to latch the command we have sent. To send the data, we have to tell LCD that it is data by making this RS pin 1. Read write will be 0 and enable we are doing high to low pulse. Here we will be sending the actual data to be displayed. For example, n character will be moving to the accumulator and from accumulator to this particular port. In between every interaction, we will be calling the delay, so that a sufficient time will be given to the LCD to settle down. Let us understand all this with one example. Here is the problem statement. Interface the LED with 8051 microcontroller and write an assembly language program to display no on the LCD. Let us describe the hardware first, how we have interfaced the LCD. P1.0 to P1.7 are connected to LCD for giving the data. That is the D0 to D7 of the LCD, and P1.0 to P1.7 of the microcontroller. P2.0 are connected